Okay, so this is going to be our day 11 of Unit 1 video for Algebra 2. In it, we're going to talk about composition of functions. So I'm going to work through some quick examples, pretty simple concept to understand. It goes back to when we did substitution to solve linear systems. That's really all that we're doing. And ultimately, when we evaluate functions for some value of x, right? So right now, first example we're going to do here, we've got two functions, well, three, f, g, and h of x, right? And we're being asked to write a composition of f of g. So this crazy little dot right there is just a fancy way of saying of, right? Um, I don't like that notation because I think it's stupid and confusing, but I'm using it in this lesson just so that way if you ever see it, you know what it means. Note that it is an open circle, right? It's not a multiplication dot. Okay, so I'll go ahead and nip that in the butt right now. Not multiplication. Okay, this does not mean f times g of x. Okay, this is not the same thing as what we're being asked to do here. Okay, so it kind of looks like a little O, so it almost looks like it says fog, right? So just throwing that out there just to make sure that we understand. Okay, what this quite literally means, what this quite literally is saying is so f of g of x is literally f of g of x. Or sometimes you'll see me shorten this even further and just say, what is f of g, right? So just like if I was asked, so here on this example, f of x equals 30 plus 20x. If I was asked to evaluate f of 4, this means I replace every instance of x with a 4 instead, right? So f of 4 is going to be equal to 30 plus 20x, right? Okay, so we know, of course, that would be 80 plus 30, which of course gives us 110. So f of 4 in this case, right, would be 110. So let's come back to the example that we started with. So if I say f of g, right, instead of f of x only, that means I'm replacing every instance of x uh, with g here, right, with g. And g also is a function of x. So what I'm going to do is take g of x and just substitute there. So if I'm doing f of g of x, right, every instance of x in f is getting replaced with g. Okay, so instead of x squared, it's going to be g of x, right, squared. Okay, instead of x squared. Right, and then of course we know g of x is right here, 2x minus 1. So that would be 2x minus 1 all squared, right? So f of g equals 2x minus 1 all squared, which just means, 2x minus 1 times itself, right? So we'd have to FOIL. Okay, so and that's exactly what we're going to do. So f of g is going to be equal to 2x times 2x, so 4x squared. 2x times negative 1, so minus 2x. Negative 1 times 2x, minus 2x again. And negative 1 times negative 1, positive 1. And we end up with f of g of x, is simply equal to 4x squared minus 4x plus 1 after we combine like terms and the like, right? Okay, so on the next problem, we're being asked to evaluate f of g of 2, right? So I would replace this x now with a 2. So I'm going to say f of g of 2 now. And what is that going to be equal to? That's going to be equal to this guy, right? Except for every instance of x, I'm going to replace it with a 2. Okay, so 4 times x squared minus 4 times x plus 1. Okay, 2 squared is 4. 4 times 4 is 16 minus 8 plus 1. Okay, then I just combine everything. 16 minus 8 is 8. 8 plus 1 is 9. And of course, f of g of 2 is simply equal to 9. Okay, so that's pretty well how composition works. Let's look at a few more examples with the same three functions. Okay, and I skipped over some examples previously, but I think they're kind of redundant. I think from that you can deduce a whole bunch. So now we're going to do h of g of 3, right? So there's two ways to do this. First, you could calculate h of g of x, right? So get the algebraic function itself first and then plug in for x equals 3. Or you could calculate g of 3 and then throw that into h. Okay, so there's two different ways to do that. I'm going to show you both. So first I'm going to calculate, well, what is h of g, right? So h of g. So every instance of x in h is going to get replaced with g. So that's negative 4 times g of x now, right? And then, of course, we continue minus 3. Okay, so I'm going to distribute 8x plus 4, and that should be a negative 8x, right? Because this is negative 4 times 2x. That gives me a negative 8x. And then negative 4 times negative 4 times negative 1 gives me a positive 4 here. Okay, so, and I can't forget the minus 3. Okay, so then combine like terms, negative 8x plus 1. And that's as far as we can simplify it, right? Well, I need h of g of 3, right? So this is h of g of x. I'm just going to call it h of g. But I want h of g of 3. So all I'm going to do is replace x, every instance of x, with this 3 here. Okay, so h of g of 3, so that would be negative 8 times x plus 1. So that'd be negative 24 plus 1, which is negative 23. So h of g of 3 for us is going to be equal to negative 23, right? And that was a whole lot of work, right? And mainly just because, this is new and I'm showing everything. But what if we didn't do it that way? What if we did it a different way? Okay, what if we did it in a more arithmetical way, right? Doesn't really matter. We're still going to get the same thing. So we got negative 23, so just to prove a point. So let's do it a different way. Let's calculate g of 3, right? So g of 3, and then we're going to take that and plug it into h as soon as we find it. So g of 3 is going to be 2 times x minus 1. So 6 minus 1 is 5. Okay. Now I'm going to take this 5 and put it into h of x, as I said I was going to do here, right? So now I'm going to do h of 5, because that is g of 3. G of 3 is 5, right? Okay, so h of 5 is going to give me negative 4 times x minus 3, so negative 20 minus 3, and holy dog crap, we get the exact same thing. Looks to me like it's a significantly less amount of work, right? And, well, gosh dang it, I should have not erased that because now I don't remember what h of g of x was. But that's what the next example is asking for. Okay, so real quick, well, never mind. I'm going to skip over that because we already did number 2. And I don't remember what it was, and I don't feel like hitting the redo button over and over again or doing all the algebra again. Okay, so g of h of 2. So we could follow the same idea as previously, right? So we could say g of h of 2. So I'm going to go ahead and do that. I'm going to calculate, well, what is h of 2 now? So that would be negative 4 times, so here's h of x. That would be negative 4 times x minus 3, right? Because I'm replacing every instance of x with that 2 inside of h. That's going to give me negative 8 minus 3, so negative 11, right? So now I'm going to take what I got for h of 2 and throw that into g. Okay, so g of negative 11 now, right? is going to be 2 times, and here's g right here for us, 2 times x, we're using that as x, minus 1 is equal to negative 22 minus 1 is negative 23. Okay, so a neat little coincidence there. All right, so now we're being asked to find the composite function of g of h of x. So we'll go ahead and do that. So g of h, right? So g with, instead of x, it's going to be an h. So here's g here. So that's going to be 2h minus 1 instead of 2x minus 1, right? And then, of course, we know h is negative 4x minus 3. So 2 times h and then minus 3, like so, right? And then we're just going to simplify where we can. So I'm going to distribute the 2. So negative 8x minus 6 minus 3. So negative 8x minus 6 and then minus 3. Okay, so now I've got g of h is equal to, I can combine these like terms, negative 8x minus 9. And that would be my final answer there. One last thing I want us to look over. Hopefully the red shows up pretty good on the black. Yeah, it looks like it's going to be all right. Okay, so red shows up real well on white, but against the black, it's a little bit harder to see. But let's look here. So we've got a table and we're evaluating, f and g using only the table. So f of 3. So again, this is basically just asking, what is f whenever x is equal to 3, right? And we can see from the table, whenever x is 3, f is 1. So our answer for f of 3 would be 1. Okay, so then let's look at g of 3. Okay, so g of 3, same idea. What is g whenever x is 3? So when x is 3, g is 2. Okay, simple enough, right? Okay, so now what is f of g of 3? Or what is f of 2, right? Because we know g of 3 is 2, so we could say f of 2. So when x is 2, f is also 2. So we've got that one just by looking from that table. And now we're looking at what is g of f of 3? Well, we know f of 3 is 1. So we can say instead of g of f of 3, g of 1. Okay, and g of 1 is 4. Okay, so that's all I've got for this lesson. Obviously, any questions, come through and see me and or shoot me an email. Goodbye. Well, maybe.